रेश्मा 10 मिनिटं झाली असतील तर आय थिंक वी कॅन स्टॉप.
ओके सर.
Announcement, Reshma. Dear participant, if your form is not complete, please don't worry. We can complete it afterwards, and we are going to get once again. So Reshma, please start with the main proceeding.
Without wasting much time, I briefly introduce our speaker, Mr. Jayant Kulkarni, who is a founder, member, and managing director of Epicons Consultants since 1985. He is graduated from VZTI Mumbai for the pursues his master's in structures in the same college. His specific interests in various areas of engineering like code provision, seismic retrofitting, tall buildings, concrete mix design, advanced entity and evaluation, conservation of heritage structures, and Indian aesthetics. The success comes from 8,500 and his technical and administrative leadership in multiple avenues of civil engineering like structural design, project management, architecture, entity, and infra. I inform you that Epicons has received Industrial Excellence Award 2021 from Institute of Engineers. Now I request Jayan sir to start the presentation.
Good evening, everybody. With this introduction, I will start my presentation. So I'll request Viha to put my presentation on screen. आपणच करायचं. Friends, today's topic is pile foundation, termination criteria, and pile testing. The topic of my lecture is introduction to pile types, methodology of selection, construction equipment, and operation. This is meant for junior design engineers and site engineer, maybe a refresher for the seniors. And even though the lecture is delivered by me, I must give credit to Mr. Shekhar Vaishampan and PP Pandey, who had helped me a lot while making the presentation, creating the presentation. So with this, what is foundation? Any structure has got two parts: superstructure, visible; substructure, not visible. Substructure, though not seen immediately, plays a vital role in life and safety of any structure. A foundation is a structure that transfers load from to the firm stratum such that existing structure is safe against shear failure and resulting settlements are within permissible limit. Not having done that, it is likely that structure may sink or may tilt, and you may not be as lucky as the constructor of Pisa Tower. That tower became world famous because of sinking. Next.
Excuse me, the slides are not moving.
आता झालं, मूव झाली. आता दिसतंय स्लाइड?
नाही दिसत नाहीये, माझ्या इथे तरी दिसत नाही. रेश्मा
फुल स्क्रीन नाही दिसत आहे. फुल स्क्रीन नाही झालं आणि मूव नाही होते. मी सांगितलं.
बरं विहा, तुझ्याकडे दाखवतेस का तू? कारण आमच्याकडे होत नाही.
सर विहा 2 मिनिटं सर बघते.
नाही विहा, यू कम हियर.
विहा तिकडेच आले सर. विहा येते तिकडे.
हा दिसतायत का नाही?
स्लाइड फाईल पहिली स्लाइडच आहे, अजून
पहिली स्लाइड जात नाही पुढे.
फुल स्क्रीन येत नाहीये
आणि प्रेजेंटेशन मोड में नहीं है. इट इज नॉट इन प्रेजेंटेशन मोड. वो फाइल ओपन करके प्रेजेंटेशन मोड में डाल के फिर शेयर कीजिए.
Now it is visible or
yeah,
not?
Now it's okay.
Yes.
So we have just wait for 2 minutes. Go back. Okay, so I start with the first slide. Again, any structure has got two parts, superstructure and substructure. Substructure, that is foundation, though not seen immediately, plays a vital role in life and safety of the structure. A foundation is a structure that transfers load to the firm stratum such that structure is safe against shear failure and resulting settlement, which should be within permissible limit. When result is the settlements are not within the permissible limit, the structure may tilt or get inclined, and you may not be as lucky as the constructor of Pisa Tower, where being inclined that has become world famous. Next. Next slide is visible now.
Yes.
So
Yes,
types of
sir. Yes, sir.
types of foundation can be but is shallow foundation, deep foundation, pile draft. Shallow foundation is actually open foundation. We say spread foundation or open footing, combined footing, mat or raft foundation. And deep foundation can be piles, piers, diaphragm walls, and caissons. And when only raft is not adequate and the settlements are more, we have got a pile draft, which is a comparatively recent concept, still in practice for 35 years. But recently, since all the buildings and towers are becoming taller and taller, loads on the foundation are increasing, and it's becoming more popular. What is pile? Pile is a structural member installed in ground to transfer the structural load to the soil at some significant depth below the base of structure. And slender structural member is made out of either steel or timber or concrete. Now terminology. This terminology is very much given in IS 2911 Part 1. Uh, there are about 19 different terminologies which has been prescribed or described. I have picked a few. I have tried to describe in detail. Of course, this is given very much given in 2911 Part 1. And pile will be discussed. Negative screen friction will be discussed. Pile center is common for both pile center and pile cutoff level for design engineers as well as site engineers. For site engineer, pile concreting level, creamy or hopper, creamy concrete with hopper, removing lattice after piling is complete, pile spacing and group effect, test load, initial and working, gross settlement, net settlement, and socketing length. Now, what is allowable load? I will describe in detail. Of course, this is given very much given in 2911. The load which may be applied to the pile after taking into account ultimate load capacity, pile spacing and group effect, overall bearing capacity of the ground below pile, the allowable settlement, negative skin friction, and the loading condition, including reversal load time. And now what we say that data what you should give to geotechnical engineer is plan and cross section of the building, governing load combination, transient load, that is horizontal load, structures nearby, and past experience. This is not must but desirable, especially if you are trying to develop a comparatively large or new plot. Even drawings may not be ready, but broadly the range of the loads which are expected is definitely helpful for a geotechnical person to plan his geotechnical investigation. And what you will be requiring as a design engineer: section of trial bores, SPT result, information up to 10 meters below rock tip level or rock top level, strength and compressibility, groundwater table, here we are saying deep foundation, but the depth of the foundation is only 6 meters because the top level is filled soil or marine clay, and we had to opt for piling foundation, even though depth is not more. And next situation, there are 2 basements. Many times there are 3 or 4 basements nowadays, and your bottom of the building, or so-called last basement, is almost touching the rock level, and you may still opt for a not isolated frame, but mat foundation or raft foundation. Now, what are the factors which decide the selection of the piling system, whether we should go for open foundation or pile foundation? Selection depends on number of parameters: ease in excavation, depth of competent strata, heavy loads. Heavy load is subjective, site constraint in excavation. Many a times it is influenced by one or two parameters at a time. One need to take a judicious engineering decision after weighing various issues.
Excuse me, can you speak a little louder, because
Okay.
we are not getting the voice. Yeah.
Okay. Now, what is ease of excavation? Normally, manual excavation is comparatively easy and cheapest. It can be very easily done up to 1.5 meters. JCB excavation can be done up to 2.5 meter. Poke excavation can be done up to 4 meter. Excavation under water table, even though lesser depth may lead pile foundation, generally open foundation or isolated foundation is recommended up to 4 meter. Either of the system can be used between 4 to 8 meter, and pile foundation is recommended beyond 8 meter. Now, please understand that these figures of 1.5 to 0.54 are not exactly
Yes, I think there is some connectivity issue. So just bear with us. Request to participants, hold on for a while. We are fixing the issue, and the presentation will start soon. Thank you.
Is it okay now? Everybody can see, Anand?
Yeah, only thing, you have to go to the presentation mode again, because the slides are not visible on a full screen.
ठीक है, आता ते खालचं दिसलं ना काही झालं. ठीक आहे, we are trying for that. There are two.
Okay, fine. We can proceed. Yeah, sure.
We can proceed. Basically, this is a photograph of open excavation, manually done. Once again, it can be very well done more than 1.5 meter. It can go up to 2.53 meters if you adopt a step method. Next, JCB, we say 2.5, but it can go even deeper if we make excavation step by step. And poke lane, this can also go much deeper than 4 meters. But basically, because of its mechanism or the action, these limits we are given. Ultimately, you have to decide based on the site condition which method to adopt, and whether we still insist on manual excavation or opt for pile. Next, how to select foundation system, pile versus open foundation, which we have seen in brief heavy load. Now, what is heavy? It is a subjective, well, it is 1000 to 1200 ton SBC, and SBC is low or medium, 30 to 60 ton meter. Basically, for this kind of a SBC, if you have got load of 1000 to 1200 tons, the foundation may overlap or it may cross the boundary. When a raft, like, or sometimes if the column spacing is large, especially in typically IT kind of a building, the raft action may not get activated. Under such circumstances, piling is recommended. Site constraint. What kind of a constraints can come? These are site specific and not general. May demand foundation because very low side margin. So if side margins are very small, there is no space for keeping the excavated material or even keeping the construction equipment. Water table is at shallow depth, so it will not allow the concreting of the open foundation, and very close adjoining structure, so your excavation may enter into influence zone of foundation. Next. Piling. Now, having decided going for piling with very careful study of the parameters what we have seen, then we have to decide upon the piling system, which is near. One is readily availability of machinery, type of structure, subsurface condition, cost and durability. These are the parameters. And category of piles depending upon the size. So I can say it is micro piles, small diameter pile, under-reamed piles, regular diameter pile, large diameter pile, and very large. Once again, these are not definitions given in the code, but they are dependent on size. And what you can say that micro pile is a little different type, not regularly used. It is normally used to strengthen the open foundation or raft. And under-reamed pile is also not regularly used. Basically, it is used whenever there is a black cotton soil. Now, rest of the type of piles are dependent on the load. And now, because buildings are becoming taller and taller, or if you want to use them for bridges, we have to go for very large diameter pile. Next. Now, as per the methodology of load transfer, we can say there are three types: end bearing piles, friction piles, and end bearing plus friction. So pile which transmit load into the firm soil layer, such as rock, gravel, virulent sand, by end bearing action. So 90% or more than 90% load, if it is transferred by end bearing action, we say it is end bearing pile. If 90% or more is transferred by friction, we call it as a friction pile. And most of the time action is in between. So it is end bearing plus friction pile. So this is the broad understanding of the type of action, how the load is being transferred. Next. If you look at very first chapter of 2911 section 1, you get various pile types. Timber pile is not defined there because that is not in use nowadays commonly. But under-reamed pile, driven cast in situ pile, driven precast pile, precast pre-board pile, and board cast in situ piles are defined, and various sections are there giving detail. Last part, precast pre-board pile, sorry, precast cast in situ pile are comparatively commonly used in MMR region because of equipments available in plenty. It has got four types, you can say, or four categories. One is baler chisel with regular tripod, with temporary casing or permanent casing. It has got direct mud circulation. It has got reverse mud circulation. These are operation dependent. And finally, most popular today is rotary or mechanical or hydraulic. Now, typical photograph of a timber pile. Normally, it is popular in northern side, especially Calcutta region, where there is abundant forest giving good supply of food. Of course, not used as on today. You can see piles are as good as concrete column and they are braced by steel member. Now, under-ream pile, these are the piles which are having bulb underground. So it can be single bulb, double bulb, three bulb, depending on the requirement. And the right-hand side picture shows that there is reinforcement cage with ties, and there is no reinforcement in the bulb. And if I show you hand-drawn sketch, it shows like a pile which is bored with either single bulb or double bulb inside. This bulb is formed by the same equipment because with which we are boring, and this has got a mechanism which flares and opens up and makes a bulb inside. But formation of bulb is many a times a question. Quality of concrete within bulb is problem, and overall concrete quality being a problem, durability is a problem. But this particular pile can be almost done without any equipment, without any machinery, I should say, because equipment is required and it is done manually. And they have very low capacity, maybe 10, 15 tons. But if you go to Latur, Usmanabad area in Maharashtra or some major portion in Madhya Pradesh, where there is a black cotton soil, these piles are popular. Next, we go to driven cast in situ pile. So these piles are cast in situ, cast in place, but the liner is driven. So there is a driving shoe, there is equipment, and there is a driving shoe. On that driving shoe, the first casing is fit along with the head, and then it is driven inside. It can be in various pieces of 1.2 meter or 1.5 meter, or it can be one single piece if your equipment is permitting that kind of a height for driving. Once the driving is complete and shoe has reached the desired position, then you can concrete it with trimming. Trimming anyway is required because most of the time there is water table and you cannot concrete during water table is present. Even if there is no water table, you cannot pour concrete height from the height of 6 to 8 meter, which will get segregated. Finally, we lower the reinforcement and of course then do the concreting. And this last figure, which is showing reinforcement not reaching bottom, this is purposely shown because earlier there was a practice of not taking reinforcement right up to the bottom, but nowadays we insist in taking at least 0.4% steel right up to the bottom. As such, reinforcement is not calculated in calculating the vertical capacity of the pile. And now, cast earlier method. This method has one problem that piles are cast in situ. So concrete, if there is a problem of sulfate or chlorides in soil, in that case it creates a problem. So driven cast in situ is these piles are driven precast pile. These piles are cast in a casting yard, which has to be nearby. There is a limitation of transportation because normally pile length would be in the range of 6 to 9 meters, and joining two piles is a problem. Difficult, but I'll show you the method how they are joined. So set criteria is decided. So once we reach the set criteria, we stop driving the pile. So typically 10 mm for 25 blows is one of the set criteria that we can assume that now pile has reached its capacity. And if at all you need to join two pieces of the pile, you can see that there is a head which is MS head. Now this all the bars which are shown, these are dowels. So this becomes the top of the pile. Right now what is shown to you is a square. It can be circular or hexagonal also. The upper pile which need to be joined has got a head of a opposite direction. There is a male female joint. This reinforcement also goes in the upper pile which is to be joined, and this type of joint is known as Hercules type of pile joint. So this also can be joined, but with great difficulty. Now this is a typical equipment which is driving the precast pile. So there is a robust frame which keeps the pile vertical, and there is a falling head, and this is giving the close-up of the same situation, that this weight is falling some definite distance and giving a well-defined energy to the pile which is going down. Also, it can be driven by double-acting diesel hammer. So the piles can be not necessarily circular, they can be square or octagonal. And we have a dropping weight method, which we saw in the first picture. diesel hammer in a second picture. Vibratory, I do not have a picture, but vibratory hammer or vibratory method of pile driving. And also there is a static method of jacking method of insertion, that is piles are inserted simply by means of static pressure. Now we come to precast pre-bored pile. So usually we have circular, hexagonal or octagonal cross section. Boring is done first. Of course, before that, fabric piles are fabricated in construction yard from reinforced or pre-stressed concrete. And disadvantage of this pile are the problem in transporting long pile, and cutting and lengthening both is a problem. This shows a typical sketch or picture. So basically for boring, a similar kind of equipment is used. There is a guide casing and there are further casing. Once we reach a hard, not necessarily hard rock, but rock under where we cannot do excavation further, we go up to that method, up to that level. Then subsequently, the pile is lowered. This pile is lowered inside. Then it is first we put water with a pressure and the entire hole is flushed, and subsequently we pour grout from the same hole, and all the side margins are grouted and pile is further protected. Now let us go to the last or important method or very commonly used method. Of course, this method also is nowadays not very commonly used because the mechanical boring is hydraulic boring is popular nowadays because many equipments are there. You can understand better from the next picture, which is actual photograph, and baler has got a flap at the bottom. So there is a guide casing which is driven inside. Then once it is gone to the desired depth, we put a extension and then we keep on driving inside. 1 minute. Tripod is positioned, and first the guide casing is pressed inside. The baler itself is used to drive either guide casing or further casing. All these casing are attached to each other by threads. Always there is a driving head at the top which saves the casing from buckling or bending. What we saw last time, that we go up to the level whereby it can go with a lower level energy by putting weights or by hammering. Once we reach soft rock level, the casing cannot be driven. So it is simply we go down by way of because of the chisel hammering. After the entire boring is complete and we have reached the desired depth, then we will flush it, and then we will lower the reinforcement and they will use a trimming concrete method and concrete the pile. Here you can see that pile reinforcement is going up to the bottom. So here you can see the photograph. It is a conventional tripod, the baler and a chisel. The picture or photograph, the sketch what you have seen may not give a correct complete idea unless you see this photograph. And best way is you must go and witness this, then only you can get a better idea. Process I already explained to you. Now we are talking about DMC method, that is direct mud circulation. So tripod and winch is similar. What is different is DMC chisel. Blow, loosen and lift is a process. So this chisel has this kind of a shape. It has got cross shape inside and circular rings, outer plates outside. And through the pipe, through the two pipes at the center, bentonite is poured continuously. So how it operates? There is a bentonite slurry tank. There is a pump which supplies bentonite. Then that pump is attached to the chisel. From chisel, bentonite goes inside. from bottom, it slows upward. So because of the blows of the hammer, the rock, whatever rock it is, soft or hard, it is crushed into very small pieces, and with the pressure of the bentonite, it goes up. Bentonite has got density little more than water, say 1.1, 1.15, and all the small pieces of the rock, they float or forced upwards, and they are taken out. For the sake of understanding, I am showing you one picture, photograph of the chisel. Here, instead of a tube, what they have put is an angle on the other, welded angle on this side. Here it appears to be closed, but basically bentonite is forced from these two pipes which are across. And one of the most important method is using, we can say, board cast in situ pile using a rotary machine. So it is a mechanical machine, or indigenous machines are not commonly used for regular work, but hydraulic machines are quite popularly used nowadays. After expressway or Mumbai-Pune expressway, a lot of hydraulic rotary machines are available in Mumbai area, MMR region. Typically, it looks like this. There is a cutting tool, there is a Kelly, and it is driven because of hydraulic energy. It comes in different categories. The capacity is defined as 130 kilonewton meter, which is low capacity, medium capacity, high capacity, and very high capacity, depending upon the diameter of the pile and kind of a rock. The drilling or which machine is required is decided. This decision, design engineer or site engineer normally cannot take, but they can always check whether whatever is equipment being ordered by contractor or being taken to the site by contractor, you should check and see whether it is adequate or which is going to be under capacity or over capacity. Now there are few photographs explaining how the operation is done. So basically, soil investigation, the report of the project is examined, survey of the site is done, and pile points are marked. Second is the rig is brought near to the center of the pile and it is aligned so that the tip of the auger is exactly at the center of the pile. Now, pre-bore 1 meter depth, place guide casing. The first casing is known as guide casing or bottom liner, keeping pile point at center, and is pressed by rotary. In case of a longer casing, it is placed in a similar way. So first, this first piece is pressed inside. Subsequently, start boring, depending upon the material being bored. Drill and take out the muck after boring. So the depth of the boring, say normally, it is always measured for every 10 minutes, and boring depth is registered or noted down. Stop boring after reaching desired depth. Normally, you get guideline from the geotechnical report, but also you can check the penetration for 10 minutes, and it reaches, when it reaches normally 5 centimeter or less, you stop, but broadly you go by termination criteria, which Mr. Vaishampan will be talking about. And now, after boring is complete, before cage is lowered, clean the bore by using flushing bucket. Here you can see the flushing bucket. In next photograph, you can see it very clearly how it looks like. After the flushing is finished, lower the cage in the bore using crane or auxiliary winch. So this is the reinforcement cage, and in this case, it is lowered by auxiliary winch. Once it is placed in position, now it is concreted. This is concreted using trimming method, and of course there is a RMC this thing, and it is being concreted using trimming. So when this piling operation is complete, remove the temporary casing. Now last part is important. Remove the temporary casing, bottom liner, by crane or second winch immediately after concreting. If you spend more time, it may get stuck. So with this, the entire operation is complete. Just few photographs to show clarity between how the tools look like. though it is full-fledged rock auger, the full capacity and anchoring teeth are seen here. This flushing tool, flushing bucket, so which basically will take out the water or muck which is there at the end of the tip of the pile. Now core barrel. After that also, what happens is you may come across a hard rock and you need to take out the rock from the core barrel. So basically what happens is you take out the rock
I think again the connectivity is lost. I think you have to unmute.
Hello. There was a problem of network in between, but anyway, I have come to the end of my presentation. Finally, there is a photograph of a trimming. The main reason of using trimming is you cannot pour the concrete from a height of 6, 8 or 10 meter. It will get segregated, or if there is a water, it will get mixed with the water. And when this entire operation is under progress, what related activities we should do is cages are made and kept ready while drilling is going on at site to save the time. Muck is cleaned from near the ring and taken away using small loader. It is ensured that concrete is available for pouring in completed bore as soon as possible to enhance the productivity. So basically a lot of logistic you need to constantly, here the role of site engineer comes, which will increase the productivity. With this, the important point where we left in between that, how to end the pile and what is the termination criteria on and what is the socketing length finally after reaching the rock. Mr. Vaishnapan will talk about the same. All the photographs which you have seen earlier, they are taken by one of my site engineer, Karbhari Bankar. So I thank him also. With this, thank you all for listening to me patiently. Sorry for the disturbance, what we got in between. Thank you.
So thank you, Sri Jayant Kulkarni, for excellent presentation. Over to you, Reshma.
Yes, sir. Our next speaker is Mr. Shekhar Vaishampayan. I'll introduce him. He has done MTech in 1984 from IIT Madras, BTech in 1982 from IIT Madras. He is a director at Subsurface Consultant Private Limited. He is having more than 35 years of experience with more than 5,000 projects in all types of subsoil condition and in types of vertical foundation, returning scheme, ground improvement, soil improvement. His slope stabilization, pavement design, for forensic analysis of failures. He is a member of Indian Geotechnical Society, New Delhi. He is a member of Institute of Engineers, Calcutta. I request Vaishnapan sir to start with his presentation.
Thank you. Thank you for your kind words. I would start by sharing the screen first. Okay. Can you see? Is my screen visible?
Yes, sir.
Absolutely. Thank you. So we are going to discuss the pile termination criteria. This is a very important part of pile foundation operation. Normally, when you start taking up the pile foundation, we can divide the operation of pile foundation into 3 parts. The part 1 is putting the or placing the or centering the pile or machine at the right location. We need to make sure that the group of the piles, the CG of the pile group and the CG of the column actually has to match, which is a very important requirement that will reduce the eccentricity to the maximum extent possible. Then the second task is to make sure that we reach right kind of foundation strata, which is that is the second task, and the third task is concreting. Now we are going to focus on how to achieve the second task of drilling the pile up to right depth or correct depth so that we have achieved the capacity of pile. Let me start the presentation with this. Okay, all of us know very well that in all our projects we go through the following familiar steps. Initially, when we go to a site, we typically conduct a topographic survey. Then we also followed up. This is followed by normally either or in tandem carry out geotechnical investigation. In the geotechnical investigation, we generally drill boreholes, we collect samples from the ground, take them to laboratory and conduct a lab test. So bore logs and lab test data becomes available. Now, once this data is put together, it is collated and taken to geotechnical engineer or a consultant. Then he will review this data and he will come up with the answer whether he requires to do shallow foundation or pile foundation. Now, shallow foundations are of course preferred foundations. The open foundations are the preferred foundations because casting of the foundation is done right in front of us and quality of the concrete also can be assured. However, there are times and occasions and reasons that we need to go for pile foundation. So let us say that it is decided that pile foundation is finalized. Now, once the pile foundation is finalized, that is the choice is not there and we must go for pile foundation. So geotechnical engineer has to now decide to arrive at or infer using the data what is the most likely safe pile capacity, and to achieve that capacity, what is the length of the pile he must actually provide or design, or that is this is with consideration each pile. That is what it means is that each and every pile will have the minimum specified capacity. That is whatever safe pile load capacity, what we rate as, whether it is vertical, horizontal, or uplift. All three are have to become part of this. What tends to happen is that a consultant actually doesn't visit the site every day. So it is not also possible to monitor installation of each and every pile. So we need to generate some kind of a simple quantitative steps which can be followed by field staff without having any doubt in their mind, unambiguously. And that so what becomes is so that is what we are going to call as pile termination criteria. The pile termination criteria thus becomes the method of field control to ensure that minimum pile capacity is achieved. I am not saying pile length. Please remember this. I am saying minimum pile capacity is achieved. Let us go to next slide. Okay. Once you have decided I'm going to go for pile foundation and you have come up with the pile length and the capacity, then we need to figure out what kind of machine method of installation is required. So typically in Mumbai region or around and about, you can say MMR region, conventional tripod method either using chisel baler or direct mud circulation is carried out, or more prevalent method today after 1995 is hydraulic rotary piling rig. These two methods are preferred methods in and around Mumbai basically, and these have been adequately and quite aptly described by Mr. Jain Kulkarni before me, so I wouldn't go there. Now what happens is, okay, so we have got through the steps that we have taken geotechnical data, we have finalized the lengths, we have finalized the capacities, we have decided the piling machine. Now you go to site and you start commence the work. You will find that depending on the quality of the geotechnical investigation data, the actual response of the founding stratum, be it soil, muram, rock, soft rock, weathered rock, whatever you want to call that, the effort applied by the machine, drilling rig, versus the response of the founding stratum can possibly be different. typically, ideally, I would say that when the geotechnical investigation data is correct and accurate, or it is reliable, you will find that fair judgment made by geotechnical consultant will yield the same data or same results. Supposing a geotechnical engineer has defined that we go for 5 times pile diameter, you will generally find that if the data is reliable and good quality, then the similar pile lengths will be achieved. They might change by a small amount here and there, but they will tally. But many a times, if the machine is not in good condition, the drilling rig is not in good condition, or the data is not reliable, or somewhat slightly dicey data, then you will find that you need to conduct or carry out initial pile trials. Now, only then you can decide upon the pile termination criteria, and we need to revise the pile termination criteria if need be, without compromising. But remember, all this has to be done without compromising on the safe capacity of piles. Let me go to the next slide. Now, when a piling engineer takes over a job, a field engineer, or I'm not saying this, I'm going to now describe to him what are the things that he requires to look for when he goes to site, and starts looking for this so that things are done in sequential manner. When a piling engineer goes to site for the first time, he should look for following aspects. The first is above ground obstructions and below ground obstructions. Are there any obstructions for carrying out the piling work? So, are there any obstructions that will hamper the movement of piling rig? Now, what can hamper the movement of what can be obstruction to piling rig? Above ground can be existing structures. We need to remove them. There could be trees. There could be there is a transmission towers. There could be bushes. There could be telephone towers, and so on and so forth. I mean, I may have missed a few things here and there, but you can imagine, because many of you are quite experienced. So, similar thing, whatever is any structure or any obstruction that is standing above ground has to be first removed before piling rig is mobilized to site. Also, similarly, there may be old foundations, there will be utility pipe, water pipes or sewer pipes, there may be cable trays, there may be a lot of other services which is going on just under the surface. So most of these I'm saying most of this would be in top 2 meters from the ground level. It is possible that sometimes some GL pipeline or some such pipeline has gone, or MGL pipeline has gone below the ground, but usually such things are marked on the ground by putting up a flag. We had an occasion that we were carrying out some work in near this Priyadarshini building, and we had to make way or make allowances for MGL's buried pipeline, and we had to wait till that pipeline was shifted out. So, but that was somewhat deeper. So, though I have said top 2 meters, the somewhat deeper pipeline may also exist. Then the next is, supposing at site, if there is a debris lying out there, if there is a high groundwater, the soil will become soft. Now, such soft soil, it is not possible for piling machine to trade very easily. There could be organic contents in the dumping ground, like you can see, let's say Devnar or place like that, or earlier there was dumping ground was there in Malad area. On all these areas, you will find that in the dumping ground, about 30 to 50% of the material is basically organic content. So this organic content, actually, when you add soil on the top, or when you apply machines on that, they will suddenly sink, because organic material will be very spongy. So therefore, what will happen is the working platform prepared? It's also very important consideration. And finally, is the site labeled for movement of piling rig? It might appear superfluous to you, but then for smooth movement of work, a firm working platform which is labeled is very important for carrying out the piling work. That will actually create or stop a lot of hassles which have happened during the progress of work, which are quite unnecessary. Let me go to next slide. Okay. Now, what is the data I should check as an engineer? See, I checked up that what is the at site condition. Now I'm going to see what do I have to do as an engineer? What is that required to do from drawing? So following that I should also check before start of piling. I should first know what is the subsoil profile. We have said in our earlier slides that geotechnical investigation data is present to you. Since the data is present to you, you actually know what is the subsoil profile. You can, for the area, let us say I'm going to carry out work in the northwest part of the plot. Which is a relevant borehole to northwest part of the plot? Maybe it is borehole number 2. So what is the stratification there? You should know roughly. Let us say that, know that. Then study pile foundation drawing. You should find out what are the pile diameters considered and provided for. We have a case study later where we have used, for example, 600 dia pile and 800 dia pile. Then what are the expected lengths which are as per the geotechnical engineers? What is his expectation? Because he has put them Corey, RQD, all that he has used, and then he has come up with the pile lengths. So what is the rock socket length and what is the top of the rock and what is the rock socket length? So that total it up, you will get total pile length. Now, concreted length of the pile will be different as compared to the total depth of the pile. So that is defined by what is known as a pile cutoff level. Now, pile cutoff level can be just 1 meter below ground. It can be, if there is a lift shaft there in the same without basement, it might go to 2 meter below ground. Or if there are basements, then the same thing might go to bottom of the basement, which may be 3 meters or maybe 6 meters or 7 meters below ground. So the pile actually has to be cast in all such cases. Please remember that pile foundation work has to be done from the ground level, leveled ground level, and excavation has to be done only afterwards. Many times the developer comes back to us and says that हम लोग पहले एक्सकेवेट करते हैं और एक्सकेवेट करने के बाद में गड्ढे में मशीन उतारते हैं और वहां से हम लोग पाइलिंग करेंगे. But such a plan actually is very hazardous because the muck that comes out of the pile holes cannot then be carted out. It takes a lot of headache. Actually, it becomes a very big headache because even water may come inside. So those things, actually considering those things, it is important that pile cutoff level actually has to be defined. If it is there in the basement, we work from the surface and concrete the pile 1 meter above pile cutoff level. Now we should obviously know as when you're concreting, what is the grade of concrete to be used and what is the steel used in the process. If we once again, typically we will use regular steel, HYSD steel, but if it is possible that we want to use CRS steel, corrosion resistant steel also. We might want to use higher grade of steel, even that is also possible. So on and so forth. I mean, all this data will come from the drawing issued by structural consultant. Next slide. Now, we have also, in one of our earlier slides, we mentioned that there are 2 standard methods. One is a tripod piling rig. Tripod piling rig is a chisel baler method or DMC method. But for both tripod piling rig is common. On the other hand, we have hydraulic drilling rig. Hydraulic drilling rig. Now, what we are going to do piling rig and see how you can terminate the piles using tripod piling rig only. Okay, let's start with this slide. There are about 4 or 5 slides of tripod only. Now, we need to first of all check in tripod rig before start of the work. What is the clear working height? Is that height sufficient? That is important. What I mean by that is that height sufficient? Sometimes what tends to happen is if you have a larger diameter pile and you have a longer chisel, then removal or the working of the pile, actually the working of the machine becomes somewhat tricky. So to prevent that kind of situation, this is done. Secondly, if it is we are working under some kind of a let us say transmission line is going overhead, and even then what is the clearance available over the rig mast side, even that becomes very important. Then second important factor is chisel weight. The chisel weight relevant to the pile diameter used at our site, chisel weight is defined. The typical chisel weight, or not typical chisel weight, required chisel weight, I would say, is 2 times pile diameter. Now, that is a very, very important factor. We'll be enlarging on this once we go to the further slides. Then we should have balers. Balers are required for excavating into soil and also cleaning the bottom. Okay, so here in the baler, once again, the height of the flap wall becomes very important. I think in the next slide is there. I can see here. In the, you can see that we have a second one is a cross section of baler. In the baler, there is a flap wall at the bottom. What is important in the flap wall in the baler is that position of flap wall is that the position of flap wall should not be so much inside that the muck will always remain below the pillar. In the hole, the muck may remain. So lesser the height of this clearance, it is better for pile, because in the pile bottom will get completely cleared up. I'll go back to earlier slide. Then the next one is hard facing of the chisel blades and collar. When you actually, let me go to the next slide again. If you are working with this thing, you will find that this face is very critical, because this is the one who is going to hit on the rock, hit on the surface, and going to cut through the rock. So this portion actually has to be coated with the hard facing material, which will actually last longer. Otherwise, the MS, these are MS blades. So the MS blades may crack after some time. To prevent that cracking, these have to be completely coated with the hard facing material. Also, important part is that these blades actually have to be also in a plus shape. They should not be in some random shape. If they are there, then you should stop them from using those kind of chisels. All the correlations that are developed in chisel penetration energy are basically meant for flat bottom A plus sign chisels. Okay, let me go back to earlier slide again. And position of cutting blades, which I explained to you just now. So you can ask me why hard facing of the collar is required. Typically, what happens is collars are provided here. These are the collars. What tends to happen is, if the length of the socket is more, let us say this is 1500 mm long, and the length of the socket is something like, let us say 2 meters or 2.5 meters or 2.5 meters, then the chisel will fully go inside rock. If the chisel fully goes inside rock and a small gravel falls inside the hole, it will jam in the hole diameter and this blade here. If it gets stuck here, then the chisel can get stuck inside, and sometimes even the wire rope will break and nothing will come out. Therefore, to ensure that such a thing doesn't happen, this is hard facing is done at this place. Hard facing is done at this area, and this area, to ensure that by friction or by that this thing with the gravel can be crushed actually. Okay, let me go to the next slide now. Okay, so
I think there is some issue with the connectivity. So,
yes, sir. Hello. There's a power cut actually in my place. Can you hear me? Hello.
yes, we can hear you.
Great. Sure. Okay. So there is a power cut. So we don't have power here. So I just gone on to supplementary power here now. All right. So following points need to be recorded while using tripod rigs. Okay, the important thing is that we need to now make sure that during pile installation, we record what is possible for field engineer to record for the following. Only 4 things can be done. One is number of chisel blows in unit time interval. Typically, for sake of convenience in the field, standard time interval of 30 minutes has been taken as a standard unit traditionally. Now, why 30 minutes have been chosen, I don't know. This has been there even before I started. When I became an engineer, it was already in practice. So it must be convenient time duration for field engineers to measure and also have significant progress. And second thing is that there is a standard drop of 2 meters of chisel. Now, this standard drop of 2 meters is very important, because it is said that even though water is the pile hole is full of water, the impact of chisel can be felt fully if the drop is 2 meters or more. But if you increase it too much more than 2 meters, you will find that there is a turbulence in the water or in the pile hole. So too much of more is also not desired. So you generally maintain a standard drop of 2 meters. So what tends to happen is, if you are measuring the number of blows in standard time interval of 30 minutes with a standard drop of 2 meters, which can be marked on the wire rope on the piling rig, then the number of blows which come there in unit time interval kind of become average number, becomes kind of standard. So, and then we measure penetration in every successive time interval. So first 10 minutes, then we can take up cleaning operation, say another 5 minutes, and then you measure how much bore has progressed. Then you actually change the chisel, attach the chisel again, do chiseling for 30 minutes, remove chisel, put the baler on, clean the hole, and then once again see how much penetration actually is increased. So the depth of the hole, hole can increase depth of the hole can be also checked immediately. Now during this process, amount of energy that is imparted actually is also important, and the amount of socket length you have achieved during the course of this chiseling operation is recorded continuously. Now we'll be enlarging on these points in the successive this thing. Now we are digressing slightly to understand what is a pile termination or a set criterion. So when Healy used this for driven precast piles, and he proposed this basic formula in engineering news record, which is known to all of us, I'm sure about that. So the original equation was Q, that is the capacity of pile, is equal to NH, that is the efficiency factor, efficiency of hammer, multiply by the weight of the hammer, multiply by the height of the fall, multiply by the efficiency of blow itself. That is divided by S is the set plus dampening coefficients, that is C is equal to C1 plus C2 plus C3, dolly, then packing, then the drop, there is a wire rope, there is a pulley. This C2 actually comprised of all of that, C by 2 comprised of all of that. So C1, C2, C3 was taken. It was combined into a sort of a constant C, and then add S to that. So what is important in this equation is that if you look at other than S and Q, everything else is constant. See, the efficiency of the blow, efficiency of hammer, weight of the hammer drop can be kept constant, and the temporary elastic compression constants C by 2 also can be constant, because all other parameters are remaining same. You will find that these are constants. So the only variables are Q, pile capacity, and set S. So the important thing here was you have to be able to achieve that required pile capacity Q, you should predefine value of S. That used to be something like for 25 blows of hammer, the set used to be limited to 10 millimeters. Once that was achieved, then it was said that the pile has got the capacity, and this could be proved by conducting pile load test. Now remember, this is an energy equation. W into H is basically work done. So that's the energy equation. So you're imparting energy to the pile, and of course the weight of the hammer and weight of the pile, they are related to each other. You cannot have a very small hammer impacting on a 50-meter long pile, not possible. So there is always a ratio of weight of the hammer versus weight of the pile. I'm talking about total weight of the pile. So this is very important, and so this is an energy equation. So that this energy concept actually has been carried forward by the further researchers and workers, and they came up with the chisel penetration energy. For conventional tripod rigs, late Mr. K.R. Date proposed in 1970 IGS annual conference a equation on a very similar line. So the chisel penetration energy E is equal to N, that is a bundled up efficiency factor N multiplied by weight of chisel into number of blows per unit time interval into H. So we can look at this. The weight of chisel is, we already have said that it is 2 times pile diameter in millimeter, which will mean that supposing I choose 600 mm diameter pile, my required minimum weight of chisel will be 1200 kgs, that is 1.2 tons. Supposing I'm going for 1000 mm diameter pile, so the weight of the chisel will be 2 tons. As simple as that. Then the height of drop, that is the drop of chisel, is maintained as a 2 meters irrespective of the chisel weight. The third is number of blows per hour. Sorry, there should be half an hour, 30 minutes. So what happens is, typically when you are dropping through 2 meter height and you have to use correspondingly adequate piling rig with sufficient horsepower capacity, so that you can give those number of blows. Say 250 to 300 blows are most common blows which are given in 30 minutes time. So if you take 1 minute, take average of say 270. Why I'm taking these values is I want to work out something in the next slide. Then there is the efficiency factor. If for a very slushy, slimy slurry, or say clay slurry in the pile hole, the efficiency factor can drop to 0.7 because there is a lot of friction, because viscosity actually increases. And on the other hand, it could be in the very hard rock, where rock and water would be, water and rock chips would be completely segregated. There the efficiency factor can be as high as 0.95 meter, because the effect will be maybe only of water only. So let us say I'm taking a value of 0.85 arbitrarily for a slightly weathered basalt. Then P is the penetration of chisel in each interval, similar to S in the Hillis equation what we saw just now, and AB is a cross-section area of pi. Now I've just put these values in this equation for 30 minutes time interval, and I come up with the answer that 2.8 is the weight of chisel into 2 meters is the drop into 260 blows into 0.85 is the overall efficiency I've selected. And because it is a 1.2 meter diameter pile, I've taken 1.13 as a cross-section area. So what I see here is that the E is equal to 1095 divided by P. Now this 1095 number 1095 side, but the figure is more or less constant. So what we say is the average energy imparted to foundation strata over unit time interval is a constant which is termed as E0, which is 1095 for our given chisel weight and pile diameter combination. Now, what was stated by Mr. Date in that paper was that he considered start of the rock socket as when the energy level reaches 75 ton meter per meter square per centimeter, then he said that he will consider rock as started. So if you put that value in this equation, then you find that the penetration is 14.60 centimeter. And similarly, hard rock is considered to have started when E value is greater than or equal to 225 ton meter per meter square per centimeter, which will mean that the penetration is 4.86 centimeter. Now, obviously, in field, you cannot measure 14.6 and 4.86. You have to round it off to say, let us say 15 centimeter and say 5 centimeter. So, to the field engineer, now you can tell that start of the rock socket is considered to have started for 1.2 meter diameter pile when the penetration of the chisel reduces below or 15 centimeters, or it is drops below that value. And hard rock is supposed to have started or considered to have started when the penetration reduces to 5 centimeter and below. Now you can use different combinations of diameters and chisels, and you can find out that these values can change. Typically, when I was young, we used to consider this value as start of the rock value as 30 centimeter and termination rock as 10 centimeter. So in minimum one diameter, now what happens is once you reach the energy level of 225 ton meter per meter square per centimeter, what is intended is that at least one diameter of the socket length actually has to extend in that strata. So in that energy level, rock having an energy level of 225 ton meter, you should go for one more pile diameter. If it is a 600 mm diameter pipe, you should advance the hole by 600 mm. If it is a 1 meter long, 1 meter diameter pipe, you advance the pile into this strata by 1 meter. Only then the pile can be terminated. Adequately or satisfactorily. There will be occasions and times, we have faced many times that also, that the energy level of sometimes the energy level of 75 or so is not reached. So there arbitrarily we have taken a call of putting the pile rock socket as 5 meters. And in sometimes when the rock is very hard, let us say if I go to Mahalakshmi side or Kulava side, you will get very hard rock. There you find that the 225 energy 225 reaches very immediately, and it goes right up to 500 or 600 also. In that case, 1 diameter socket is not possible. Then you might have to do with 0.5 times pile diameter as a sort of a, shall we say, the via media solution. Ideally speaking, chisel penetration energy method works best when you don't reach 225 as a termination depth, but you are reaching somewhere around 160 to 200 as a termination energy, and there you can go for 5 to 6 or even 7 times pile diameter as a socket length. This we have seen as a very satisfactory measure or satisfactory method of terminating the pile in the moderately hard type of rock. It's a very good system for that. Okay, so very few people now have known the details of chisel penetration energy, and it is not successfully employed by most actually. Without people, mostly you employ it without understanding this. So I endeavored to explain this in detail. I hope it has reached you. Now we'll go to today's method, hydraulic rotary pile. Now in the hydraulic rotary machine, what are the things I should check? In the first we checked in this thing also. What are the checks we made on the machine? So what is the machine rating? In the machine rating, what is most important is RPM versus torque chart. This is a very important data which should come with every machine. Then what is the condition of machine? Is the machine in decent condition, good condition? Is it in good operating condition? Is it serviced properly before coming to our site? Or has it done, if it has done too many piles before coming to our place and it has got fatigued, then this requires reconditioning. So condition of machine is very important. Then what is the kind of pull down force it applies? What I mean here is that I got a pretty hard rock. Say let us say crushing strength is more than 30 MPa and my pull down force is less than 10 to 12 tons. Then probably this machine will not be able to cut through the checking on the mass side is also very important. Then condition of soil and rock auger. See, many of you may not know that, or may not know that are two different type of augers are used in the soil and in the rock. The number of bullets that are used are, and the type of bullets that are used are different, and the shape of the auger is slightly different. In soil, the main objective is to remove the cuttings rather quickly and in bulk quantity, whereas in rock auger we need to cut and cause failure of the rock under the pull down force. By applying an adequate pull down force, we need to fail the rock every time. So the angle of the bullet becomes very important. Okay, then quality of bullets. The bullets are basically have a core. In the core, bullets are carborundum, which is our tungsten carbide. It's actually are inserted in the bullets. Now these actually are very important because the quality of bullets actually become very important, because when you're cutting through the rock, for cutting through the rock, you require adequate strength. Angle and strength also becomes very important. So quality of bullets are also important. And last but not the least, because when you cut with the auger, there is an incline at the bottom. So pile, our pile is not designed as a, shall we say, friction pile mostly. It is basically designed as a end bearing cum friction pile. So to be able to achieve the full end bearing, then the pile hole has to be cut properly with a flat bottom. To be able to do that, we require a cleaning bucket, which was shown by Jayan sir earlier. Let me go to the next slide. Okay, so what are the field records you can maintain here? So we can maintain, once again, just like tripod rig, we will maintain penetration in successive time intervals. So standard time interval here also is 10 minutes. Then the kind of pull down force that is applied while carrying out the work, and what is the pressure gauge reading. Then the third most important part is what is the Kelly bar RPM. When you are carrying out the work, the main circular bar which goes down to which the auger is attached, that is called Kelly. Now the Kelly bar actually is rotating. Now the number of rotations of Kelly bar vary from as many as 30 when they are working in the free condition, that is no load condition, to down to 9 to 10 RPM when they are fully loaded. So Kelly bar RPM actually has to be recorded. Why it is to be recorded will come in next slide. I will explain to you. Then we have to calculate pile penetration ratio, and then finally with that, what is the socket length we have achieved. Let me go to the next slide. This is a very important slide again. So if you compare this equation, pile penetration ratio, this was proposed by late Dr. V.T. Ganpule, who was also professor in VJTI for some time, and a very well-known personality in this thing in the Mumbai area. And he proposed this method when the machines became very prevalent in 1996 to 2000. There was no control as to how to determine how to finalize this. So he said that the chisel penetration energy method, which is proposed by Mr. Date, he will use a very similar method, and you see the similar equation. Pile penetration ratio has got a very similar equation. I would not go back to that slide right now, but we can just see that energy divided by area of the pile and multiplied by penetration. So in PPR or pile penetration ratio, the N is the revolutions of Kelly per minute. And interesting thing is the equation is 2 pi n t into time interval t. Now time interval t is 10 minutes. So in the given time interval, we have revolutions. RPM of the Kelly is given n. Now the t is not measured anywhere, but it is measured from the graph which is the next slide. Look at this graph. A typical RPM versus torque chart is presented below. You can see that when the RPMs are high, the torque is very low, and when the RPM go on dropping, you can see torque increases. This is very similar to what we do in car driving. In the car driving, when you are actually having first
There's some issue with the connectivity again. I think today's webinar seems to be very exceptional, and we have a lot of interruptions due to the disconnectivity of the net. So wait for 2 minutes. Mr. Vaishampal, he will rejoin, and we'll be able to start the presentation soon. Just wait for 5 minutes. Reshma, meanwhile, can you just introduce Mr. P.P. Pandey, next speaker?
Yes,
Hello,
sir.
Reshma.
Yes, sir.
So we have the next presentation.
Hello. Should I introduce our next speaker?
Sorry, Kamali, mobile na?
Reshma, please.
Okay. Our next speaker is Mr. P.P. Pandey, civil in 1982 from Ravi Shankar University, Chhattisgarh, working with Epicons Consultant Private Limited since 2003 as Senior GM Projects. He is heading Project Management Department. Is a hardcore concrete technologist. He has more than 35 years of experience in the field of bridges, piling, infrastructure development, greenfield projects of various categories like residential, commercial, institutional, and industrial. He has worked with hardcore infrastructure and piling companies like AFCON and I request Pandey sir to continue with the lecture.
1 second. I think let's first try to understand whether Mr. Vaishampayan is going to
confirm कर लीजिए
presentation or
सर आप कंटिन्यू कीजिए और शेखर वंशम सर आपके बाद
कंटिन्यू करेंगे.
ओके ठीक है.
Okay, so Pandey ji, you can start your lecture.
या शेयर करने का दे दीजिए.
And Mr.
Yes, sir,
Vaishampayan
already.
yeah, Mr. Vaishampayan will complete his presentation after we finish with Mr. Pandey's lecture.
Pandey sir, you need help? Should I come?
बेल वाजवत होता ना?
नाही नाही, मला हातच फिरते.
नाही, मगाशी वाजवली होती तुम्ही.
मगाशी
Yes. Hello. So Vaishampayan sir has given me early opportunity to start. Okay. I hope the slide is clear to everyone.
Yes.
You can just go. You can, if you can just turn on your presentation mode, then we can see the full screen slides.
It is already in the presentation mode, no?
No, we are seeing the slide in a small version and side by side other slides also.
अरे हाँ, तो क्यों नहीं दिख रहा उनको? मैं तो कर रहा हूँ. दिख रहा है अभी?
नहीं सर, आप स्टॉप शेयर कीजिए और फुल स्क्रीन
अनंत.
करके शेयर वापस कीजिए.
इसको बंद करो जरा।
Ah, yes.
एक तो दो फाइल खुला हुआ है। अभी दिखा क्या? नहीं। तो फिर रहने दो, ऐसे ही करते हैं ना। हाँ, आ गई जादूगरनी। चलो।
Pandit, you can start, no problem.
इसी किया था पहले।
हाँ अभी ठीक है। हाँ अभी ठीक है।
ऑलरेडी प्रेजेंटेशन मोड में डाल के फिर शेयर करने का कोई फर्क नहीं है। ठीक। Hello everyone. So now I'll be speaking on the file load test. Or say testing of the file. Load test is one of the part of it. Basic requirement of file is that resistance from soil should be more than the probable loads during the lifetime of the structure with adequate factor of safety. Now we call it pile capacity. So as you have listened earlier, that while driving the pile or while installing the pile, we are using energy criteria to ascertain that the pile has enough capacity. But the piles are not actual life. The piles are loaded with static load or a constant load. So the function of the pile is different in actual life. And therefore, we need to do kind of testing whether adequate capacity has been achieved. And therefore, load test is very conventional and very much required. We do the test on the piles to know the load bearing capacity of the pile and to know the settlement characteristic of soil. Mr. Jain Kulkarni had shown a world famous building, Leaning Tower of Pisa. We also have a Leaning Temple in Varanasi. And these are because of uneven settlement of the strata. And therefore, to understand the settlement characteristics of soil or the strata is very much required, especially when there are friction piles. That may not be so much required for the end bearing piles. Now, there are mainly three kinds of testing which is conducted on pile. There is one static load method in which the actual weights or reaction loads are used to press down the test pile and to note the settlement. There are two main types of the load test. One is initial, another is routine test. And there are three methods: maintained load, cyclic, and CRP, constant rate penetration test. Now, if you go to this code 2911, these three methods have been briefly described. Maintenance load method, this is applicable for both initial and routine test. In this method, application of increment of test load and taking of measurement or displacement in each stage of loading is maintained till rate of displacement of the pile top is either 0.1 mm in first 30 minutes or point. In nutshell, we do loading in increment of 20% or 25%, and we wait for 30 minutes, take the settlements, then for every 30 minutes we keep the measurement till the measurement becomes almost constant or very minimum 0.2 mm, 0.1 mm, and then we repeat the loading process. So this is a maintained load method. And the cyclic method is almost same. Only thing is that we measure the rebound of the pile while doing the unloading in the similar fashion. If we had done loading at 20% increment, then we unload it also at 20% increment, and we measure the rebound of the pile because it comes up. So that measurement is taken, graph is plotted, and this method gives not only the capacity but also the characteristic of settlement and rebound. And there is CRP method, which is generally not very less common. In this method, the rate of penetration is maintained constant and the load is changed by changing the pressure of the hydraulic jack. But this is not used more often. So this was the static load method, which I will explain later. The three methods: maintained load and cyclic and CRP. Then another method is of testing pile is low strain indirect integrity test. This is ultrasonic test. This is very common, very fast, and not much of preparation is required. Just the pile tap has to be prepared, and being very fast and very cheap, almost 100% pile testing is done. It is very common in Mumbai region, and most of you who are dealing with piling must have come across this kind of test. The pile tap is given a small impact force. It's with a small hammer, which generates a pressure wave down the pile. The deformation in the pile and pile soil interface generates reverse pressure waves. Deformation in the sense of honeycombing, voids, bulging, necking. So all this physical deformation in the pile, maybe that large deviation in density of the concrete. These all defects, they give reverse waves, and these waves are detected by the sensor, and that time of arrival of the waves, intensity of the waves, these are plotted against time, and that is the way to understand whether the pile is okay. And point to be noted for this test is that it is not a load test. We don't really test the capacity of the pile or the pile soil interaction. We only ascertain that the pile is sound. The concrete in the pile is sound. The overall diameter or cross section of the pile is okay. So basically, it is a test for soundness of the pile itself, and not the measurement of capacity of the pile or the settlement of the pile. And then there is a third method, which we call it high strain dynamic load test. Few of you must have come across this, in which a very heavy hammer is dropped on the pile, and pile is provided with movement sensor, accelerometer, and other sensors, and that acceleration under that impact is measured, and that is used as a tool to determine the capacity and also the settlement of the pile, settlement behavior of the pile soil interactions. We will skip other methods like there is sonic logging, cross hole sonic logging, lateral load test, pull out test. So there are many other tests on the piles, but which are not very much common. So we'll skip that. Now this is the typical photograph of a static load method. These concrete blocks, there is a platform created on the over the pile, and then a static load is put. This load may be 2 times or 2.5 times the 2 times of the ultimate load what we are intending to put on the pile. This is a schematic. This is diagram for the same static load test. You can see that there is a hydraulic jack. There are datum bars to measure the settlement. There are dial gauges accurate to say 0.01 mm. And this arrangement is provided for static load test. Load is applied at 20-25% increment, sustained for some time, maybe half an hour, 2 hours, depending on what is the kind of penetration. In friction pile, it takes more time because it keeps on settlement keeps on increasing. Whereas at for the end bearing pile, this is not the case. There are not much settlement, so interval can be very small. And there are two criteria that for initial test, the settlement is 12 mm, and it is 12 mm for the both. The final settlement should not exceed 12 mm, or the load test is stopped at 12 mm, unless it is decided in the for the initial test that we'll go for more settlement to understand the behavior. So that is a different case, exploratory kind of testing. Routine test is generally 1.5 times the working load and design load. This is the same static loading method, but it is not using the gravity as a applied load. Instead, anchors are driven into rock, grouted into rock. They are pre-stressed wire, which are grouted in the rock strata below, and the hydraulic jack is placed against this beam, bearing beam, and the load is applied on the pile using the reaction of the strata through this kind of arrangement. So, and this is very common because you don't need a lot of gravity load, and this is really much simpler. As I said, the cyclic load, we measure the settlement, downward settlement. We also measure the uplift of the pile while unloading the load, unloading the weight. So this is the kind of typical graph which is obtained. This is the settlement while loading. These are the intervals. You will see that the settlement keeps on decreasing for the same interval of time. And then it becomes for 30 minutes. Then we start unloading. And you see, this is the rebound curve. This is rebound curve. The settlement keeps on decreasing as the load is reduced. And you will notice that the pile does not
Sir, screen share stop.
yes, I'm seeing there is something wrong. Again, stop share. Can you see this thing? Is the slide back? Hello.
Yeah, it's there. Yeah,
Yeah.
you can continue.
So you can see that the pile doesn't rebound fully. There is a residual settlement of the pile, and that is why in routine test pile is not loaded to great load. Otherwise, the residual settlement will make the pile unsafe. This is the photograph for low strain testing. You can see that person is using a very small hammer to tap the head of the pile, and you can see the sensor which is just by the side of the hammer. This is the typical arrangement of data acquisition system for the this kind of testing. There is a hammer, there is a sensor, and there is a computer system, because without a sophisticated computer program, it is not possible to analyze this kind of data. These are in microseconds. The travel is in microseconds, and the voltage and currents are in micro amperes or nano amperes. So very sophisticated systems, computer systems are required for this. This is the kind of output which is obtained. These are the amplitude in a amplitude of the waves against the time, and it is made by the computer. These are the initial waves. This is the final wave at the from the toe, and seemingly a good pile will give this kind of graph. Seemingly bad pile will give this kind of deformation in the wave. But we should not try to interpret, because this requires understanding of pressure waves, time, sensors, computer, and all those kind of behavior of dynamic behavior of the say elasticity of the concrete, and so many things. So we should not try to interpret from the graph. This is just for example. This is another way of giving the same output. Different outputs are possible from the computer. This is not actually the shape of the pile. It's not that pile, this is giving shape of the pile. Actually, this is giving only deformation of the pile. If suppose the density is very high somehow in this region, then it will show as a bulging. And if there is a void or something, then it may show as a necking, though the cross section may remain the same. So, but the output shows as if pile is having so much physical deformation. So that's not exactly the case. This is the working principle. The sound waves are these pressure waves. They travel downward, and then they are reflected from the soil and concrete interface, and sensor picks up the wave, returning waves. The sensor determines the time which waves has taken to come back. Based on the velocity of the pressure wave in the concrete, the computer determines the overall length of the pile, because this test can give overall length of the pile. And in the second sketch, you can see there is a necking. Wherever there is such deformation, necking, or there is a discontinuity in the concrete, or there is a bulging in the concrete, there is a secondary waves which travel backward, and they are measured by they are detected by the sensor. The time is measured by the computer software, and depending on the nature of the returning wave, whether it is a positive wave, negative wave, the location of the defect and the type of defect is determined by the software. Then the third test is a dynamic load test. In the dynamic load test, quite a heavy hammer is dropped on the pile. This pile cap requires a very good kind of preparation so that it should not get shattered. It requires a MS cap, extra concreting, then there is a MS plate on that to take the blow. There is some cushioning also provided, which affects the efficiency of the hammer, which Mr. Shekhar Vaishampayan has spoken in the formula. The efficiency of the blow is affected by this. Now this test is very fast, but it is not as simple as low strain because it requires crane, it requires very heavy load. Many a times there are safety requirements. Here it is simply using crane and dropping the hammer. Most of the places in many places we have to provide structure steel framing. Now this is the data acquisition system. You can see this. This is hammer. These are the reflector for measurement of the acceleration. There is the theodolite has to be. It is a special equipment, not a normal theodolite, because it has to measure a very small movement, and that too with respect to time. It has to measure the acceleration, not just the settlement. And it is all attached to a software system which detects all this movement and records the movement against time. So now this sketch I'm not going to explain because even I don't understand much. Only the scientists, they understand this better. But I'm just showing it for the purpose of telling you that how complicated it is. It is not very simple that we drop a hammer and then we measure acceleration and we give pile capacity. There is a lot of scientific research, scientific data and understanding is required. A lot of mathematics is involved in this. The whole pile is considered to be made of finite 1 meter sections of a structural element, and soil is considered as some kind of spring, and these pile and soil interactions are represented in the form of spring and solid masses, and so that so many things goes into that. So I'm just giving this sketch just to explain you that there are really quite a good amount of knowledge goes into creating this kind of test and this kind of software. This is a typical output. This is a typical output where you see this. The one benefit of dynamic load test is that with this test you can find different component of pile capacity. You can find end bearing capacity component. You can find friction component. You see here it is shaft friction. That is a friction component of the capacity of the pile. This is end bearing. This is the end bearing component, that is tip of the pile. So you can find this these two different components. So that is not possible in low strain, and that is possible in load test, but that is a different kind of calculation required in that. This is another kind of representation of the dynamic load test, where you can see this. There are three different graphs. This is the when the impact is taking place. This is happening in microseconds. The entire graph is represented in just microseconds. This is when the pile is going down. This is when pile is rebounding after the impact. And these three graphs are for say drop of 1 meter, drop of 1.5 meter, drop of 2 meter. For better analysis, the weight is dropped from different height and the graph is plotted. And this also is this also eliminates error in measurement or sensor or whatever. And if the three graphs are identical, and then it itself is a proof that test has been very proper.
Yes, Pandeyji, I think you have to unmute yourself.
Hello.
Yes, you can go ahead.
Okay. So you can see this in this sketch that there is a receiver, there is a transmitter here, and then there is a receiver here. Transmitter and receivers are both, they are lowered in the pile shaft at the same level. And the receiver, it detects the time taken for the sound wave to travel from the transmitter to the receiver, and that is transformed in terms of soundness of concrete. The principle is simply simple as a low strain method, where it is the impact is given on the top sound and the pressure waves are measured from the top. But when the pile diameter is very large or the pile length is quite long, then the surface detection becomes it may involve a lot of error. So this test is adapted for very large diameter pipe and very large length of pile. So this is called sonic logging, crosshole sonic logging.
Achha, Pandeyji, we missed your previous slide. So which test you are talking about?
Sonic logging.
Okay.
Cross or sonic logging.
Okay, fine. So this was the last slide, and after that there was a disconnectivity.
Correct. This is sonic logging.
Okay.
Which I explained. This is the kind of output which is given by the sonic logging test. Again, it is to specifically note that this is not the shape of the pile. It is not that the pile looks like that. In fact, the voids and defects here are shown as a bulging, but it is result of the defect in the pile in the form of voids, or maybe large variation in the density, or maybe honeycombing. So this will need to be understood from the point of view the pile data, that if you can get any hint from the pile data that what kind of problem must have been occurred during construction. So we can try to interpret whether this is because of honeycombing or voids or because of necking. So that it involves some kind of a speculation. But the test definitely says that there is something wrong, even if you don't know what exactly is wrong, but you know that something is wrong. And then you have to take decision whether the pile is to be used or alternate pile has to be provided based on the quantum of deformation and not the type of deformation. So there is a kind of speculation, and that's why it should be done by only quite experienced people and not by any general engineers. This is another kind of output of the same project. Here the time of arrival of the waves are plotted, and now you see there is a defect here, and there is a suddenly there is a waves, counter waves which are coming at the uh, at the longer time, because the waves have to travel around the defect, and that's why it takes slightly more time than what it takes when the concrete is sound. So that kind of time lag is measured as a defect. So it is a very much indirect measurement. We may not be able to know exactly what kind of defect, because honeycombing, white, snaking, all the three kind of defects will be represented by the same. There are codes available for that. IS 2911 is for static load test procedure. All the three procedures are given. The parameters are given. IS 14893 is non-destructive integrity testing of pile, which is very commonly called integrity testing. And ASTM D494589 is dynamic load testing of pile. There is no Indian standard code I could find for this. All these three codes are available online, and it can be downloaded freely. At least two I have done. IS code I have downloaded. Yes. STM I couldn't. Now I will be